we're going to be talking about Verilator. It's a very good open source program which can help you tremendously. If you are a student or if you are a professional but you don't want to buy a license for expensive EDA tool, Verilator is open source. It's free. You can use it to lint check to simulate your Verilog SystemVerilog code. You can go to the you can Google Verilator and it will take you to their website. You can install, you can read documentation about it from their website. As the website stated that Verilator can accept Verilog or SystemVerilog code. It can do lint check, sanity checks on your Verilog code, compiles Verilog into multi-threaded C++ code or System C, and it also can create JSON file for your other tools. All right. If you are working on Ubuntu Linux under Linux environment, you can just simply do a Google search how to install Verilator on Ubuntu. Two commands, sudo apt update and sudo apt install Verilator. That will get you a quick installation of Verilator. All right, I have installed on my machine, but just to show you how you can install, sudo apt install Verilator. You can use this command to install on your machine. Okay, since I have installed it and you want to check whether your installation is correctly installed or not, you can use the command Verilator -version. As you can see here, it gives me a version number. It indicates that the tool has installed correctly. Some of you are smart, but some of you may need some help how to get started with Verilator. I have put through some small examples and how to execute and how to compile and what you can do. So first of all, let's see a simple Verilog file, SystemVerilog file. So an example I have created here, a flip-flop example. As you can see here, I have named it hrflop as a module name. Different parameters, inputs, outputs with the enable condition. You can write more complex logic as you want. Line number 13 says that the intention is to create a flip-flop with a clock and reset and enable condition. This code, line number 13, will correctly synthesize. Okay. Line number 15 to 19, I have put display message, which is normally verification engineers use it. For RTL, you don't have to put it there. But just to give you an example that I want to display this message on a screen. Okay. So a simple code. Let's now try to do a lint check. Okay. Verilator, you can use this command -lint only. Since there is no syntax error, you don't see an error, but let's say intentionally I create an error. Okay. So for example, let's say on line number 13, I remove this semicolon there just to create an error. Okay. Now, oh, seems like I did another mistake here. So let's see what else I did do. Okay. So let's save it here. And let's try to do lint check. As you can see here, expected error message. Let's correct the error. Line number 13. Okay, Good. So we have corrected at the error. And let's try to do lint check again. All right, so there is no lint error. Your code is good. Now, how you can build and create the C++ and executable files. So there is another command which is Verilator. This is another command. But before going to the command, we have to create a CPP file. Okay. So let's see, which will act as a main CPP file. Okay. So I have written already the CPP file. The trick in this CPP file is that the V stands for Verilator, is caps, and then HR flop is the module name. So in my case, module name is HR flop. So V stands for Verilator and then your module name and .h. This header file will get generated after the successful build by Verilator. And this is an internal file. You have to use as it is, verilator.h file, header files. And line number 3 is a standard code for CPP, int argc, corrector, pointer, argb. Okay. Line number 4 is a standard Verilator code. Line number 5 is standard Verilator. The trick is at the line number 6. At the line number 6, V stands for Verilator, and HR flop is your module name. In my case, HR flop is my module name. Okay, and then the pointer sign, asterisk sign, and then top here you are creating or indicating the program to create an object of type VHR flop. Okay, and then V stands for Verilator, HR flop is your module name, and the context B you have at line number 5, right? And line number 7 is a simple while loop. Okay, standard. And then after you execute that while loop, you delete all your objects. Okay, simple code. Nothing much to explain here. You can keep it as your main CPP file, and then you can include other files or more complex code you can create. Okay. Now let's go back to the how to build it. Okay. So you have this command Verilator -cc. -cc option indicates that it has to create C++ file. --exe indicates executable, and -- build option tells Verilator to call the make utility. And -j0 tells Verilator that it can use as many threads as the machine allows where Verilator is running. And then -wall option says stronger warnings. Let's say in your code you have some warnings, and also it says strong checking on the warnings, which is a good thing. And then you put main CPP. In my case, I'm calling it as a sim.cpp. And then your module HR flop, in my case, module Verilog, system-verilog file. All right, so let's try this command. Okay, seems like it's working. It's doing its job, what it is supposed to do. And seems like there is no error, no warning, and it is supposed to leave executable and other files under obj_dir directory. So let's see, what did it create? Okay. So this has created a object directory, and if we look inside the object directory, we see a bunch of files, CPP files, header files, object files, and whatnot. Okay, so you can read more information about each of these files on Verilator documentation or Verilator website. You may find the link to how to download their documentation there. Okay. And now let's see, we have put a display message in our Verilog file, and how does it execute? So it's a simple command. You go to the object dir, and it has created VHR flop and execute it. So if you execute it, it displays the message which I have put under Verilog file. Okay, So that means that it's all good. So similar way, it was a small example. You can create more complex Verilog code, and you can use Verilator tool to compile, lint check your code for sanity, and further you can simulate it. All right. Um, so that's good. I have put some information on Verilator related on my website, LeProFesSeur.org. So I'll show you in a second. If you go to the website called LeProFesSeur.org, if you click on the useful links, and then you go to the Verilator open source Verilog system Verilog simulator. So what I was talking about, the few commands, options, how to install, you can simulate, you can do link check on my website. So that's it, guys. It was a quick lecture on Verilator. I hope it is useful to you. Let me know how do you do that with Verilator. You can send me a feedback on email, hr@leprofesseur.org. Also, if you are a student, you are struggling, you need some guidance, help, or uh, any sort of questions related to what I'm here explaining, you can leave me a message. We can set up an online meeting just to help you out. Sometimes some students are smart, but some students are struggling. If you are struggling for any reason, you need guidance, you need career consultation or whatnot, we can have a quick discussion and see if I can help somehow. All right then, thank you guys for listening. Have a wonderful day. Bye for now.